In our last episode, we spent some time taking the first steps to interact with DBus. We use sdbus-c++ library to send messages to DBus and interact with Bluez, the Bluetooth implementation for Linux. We did some fairly basic operations, but we wanted to do some more, and this is the time to do it. In this episode, we will try to finally connect and read from the sensor. So let's get cracking. Well, that looks like progress to me, but we're still missing the most important features. We need to connect to the device and read values from it. We should connect to the BLE device from the closure that we use in subscribe to interfaces added. And then we should stop scanning. However, that closure and the method scan and connect, which is where the stop scanning should happen, are running in two different threads. We should find a way to inform the main thread, scan and connect one, that we have connected to the device so it can stop discovering devices. We are going to use a mutex to protect the data that is shared between these two threads, and we will be using a conditional variable to signal the main thread that the connection is ready, is established. We're going to declare the private method that we're going to use to connect to a device by name. So let's get rid of terminal and let's declare it in the header. So we go to header, and here we're going to have this new method that is going to be connect to device, and then the object path that we have selected. Let me remind you that the object path is one part of the data that comes with a signal. Then it comes a dictionary that may have a name. So we will be using for the name, and the path that we select will be used with this method. The thing is that we want to obtain that from the signal, but we need to provide a name. And that means that we are going to provide that name through the constructor. And instead of using this constructor, we're going to have this other one that takes a string as the requested sensor name. Okay, now that we have this string, we would also like to have a field that holds the data for the name. So let's put that here as another string of the object, and that will be set by the constructor. And once we have connected to the selected device, we will need another proxy like the two that we have already selected, like these two. And we are going to have this proxy here. This proxy is going to be to the device itself. Okay, so now that we have all the infrastructure, let's go with the initialization. Let's go to the CPP and let's change the constructor that we have. So here we're going to have a different initialization. Let me get rid of the old header for the method. And we are using the preamble here. We don't know, we cannot create the device proxy because we don't know what the object path is going to be. And even if we knew it, we don't have access to it until our Bluetooth is scanning. So we initially set it to null pointer. So it is empty. We cannot use it. As for the device names, we get that from the parameter that has been passed on to the constructor. Okay, so now that we have set the two new variables here, we can go and define this private method. Let me go to the bottom of the file, and here I'm going to create the method. What am I going to do here? Well, The thing that I would like to do is, now that I have been passed a path for the object that I want to connect to, is to create actually the device proxy using the path that I have been provided with. I am going to also use the service Bluez constant, and that was used in the initial constructor here. But since we are going to use it in two places, we don't want it here. We want it in the header file. So let me go to the header file and let's create a new inline constant. Let's move this here. That contains our rules here. Now this is available not only to the constructor, but also to the connect method. Okay, so what do we do with that? Well, in order to connect, we need to use the device proxy that we have just created. Let's go there and go to the bottom of the file. And here, once I have created the proxy, I'm going to use it. I'm going to invoke a method, in this case, asynchronously, and I'm going to use this connect method from this interface device. And upon reply, so asynchronously, I will be invoking, well, the library will be invoking the connection callback that I will define immediately. I just print this to know that things have started but have not finished yet. So now that we have that, we are going to define the constants here, the ones that we were using here, the method connect and the interface device, and I would also like to define the closure. So I do that here too. Again, I'm capturing the instance of the object that I'm working with, and this closure is able to receive an error in case it occurs. So if something goes wrong with the connection, it will receive an error, and I will be able to print information about that here. The way I'm going to use this, and I will complete the closure in a moment, is when I have a name that matches one of the signals, then I will try to connect to it. And if you remember, the place I was checking for the names was here in the subscribe to interfaces added, that I have this expression checking that it is a device, and then I check in the dictionary whether it has a name or not. So here, I know that what the name is, and what I'm going to do is use this name in order to connect to it. So if the name is the one that I have been told to connect to through the constructor, then I will try to connect to it, I will print the message and use the method that I have just created. And that is so good, but we would like to do a little bit more than just connecting. Once we have connected, let me go back to the public method that we were using. We were doing this. We were subscribing to the interfaces. That's where we will be connecting. We enabled scanning, and we waited for some random time here, 10 seconds, and then we stopped scanning. What we would actually like to do is to know that we have connected to the device and then stop scanning right away. So let's do that. Let's create the variables that we're going to need, fields that we're going to need in order to implement that functionality. So here in the header, I'm going to declare a few more fields. In this case, this is going to be a mutex, so a mutual exclusion thing for us, and a condition variable. The condition variable allows us to signal from one place to another, and then we can use the consumer-producer concurrency pattern in order to implement this. So what we're going to do here is to have the right header in order to have this accepted, compiled. And with this in place, we can use it from the method that we were using. But before having the method using it, we would like to initialize it. So we go to the implementation file. And here in the preamble, I was initializing the device name and the device proxy. In this case, what I'm going to do is I'm going to have this other initialization that is a little bit more complete, that takes the device proxy and initializes to null pointer as before, and the device name with the sensor name that we have been provided with, and then the conditional variable and the mutex are initialized, and we have this property that is a flag to say whether we are already connected to a device or not, and it is initialized to false. Okay, so now we can go and move to the method that we have the connection. And in this method, we're going to get this here. This is where we subscribe to the interfaces added, then enable scanning. Hopefully here we get connected and then disable scanning. Before doing that, we're going to obtain an instance on the log, on the mutex. So we will get this log by using the mutex that we have created, and if the mutex is available, if nobody else is running on that zone, we will subscribe to the interfaces and enable scanning. And here, instead of waiting for the connection to happen and a little bit longer maybe, we are going to replace this with, sorry, because this is duplicated, so let me remove the things that are not required. So here can remove this, and I can remove this. So I have the same enable scanning true and false that I had before, but instead of the delay, now I have wait for the condition and variable to be notified, to be signaled. And it uses the log to be able to have access to the information, and it uses this closure that takes the instance of the object and verifies if these objects connect the flag that is a field of this object has been changed to true. If it is, that means that I'm connected, and then I will stop scanning. Pretty easy, isn't it? So let's go and do the other part of this contract on the closure for the connection. Let's go to where the connection was happening. And here in the connect to the device method, we're going to work in the closure that we haven't completed yet. So the first thing that we're going to do is to deal with the error in case it happens. If we have an error, we don't want to continue, we want to print the information, and that should be it. But if there is no error, what we're going to do is to work with the data that we have. And here we are going to obtain a log for the mutex, say that we are connected, say that the connected flag is now true, then we unlock, because we wanted to have exclusive access to connected while modifying it, but now we don't need that anymore, and then we notify the the threads that are waiting for this to happen. In this case, the main thread. And we just print the message saying, hey, we're done here. So that should be all we need. The only thing that has to be changed in the implementation of main CPP, that as you can see there is in red now, is that now we need some value to create an instance of the BLE sensor. So we're going to do that and provide the name of our sensor here, and that should be more than enough to have our sensor selected. Let's go and run this. First, let's compile. And if we can connect to the device, then the scanning will stop immediately. The only thing that we are not doing here is that it will wait forever if we cannot connect to the device. So it has detected the RP2 sensor, and we are waiting for the connection to be finished. The connection has started, but it is taking a while to happen. And then it has connected, and immediately we get the stop scanning message. Now that we have a connection to the BLE device, we will be receiving signals about interfaces added. Those interfaces will be the services, the characteristics, and the descriptors of the Bluetooth stack. And we want to be listening to these signals. We already have a closure that is paying attention to these signals. However, that closure is focusing on devices, on BLE devices. We are going to change the code so it will also be listening to characteristics, so we can find the right characteristic using its UID, and then use the read method to get the value from it. We are already receiving information about the devices that we connect to, and using the same subscription, we will be receiving information about the paths. But we need to deal with it in a different way. So let's go to that method that is in the implementation, and we should go to the subscribe to interfaces added. That is where we are listening to these signals. Thing here is that we are going to behave differently if we are already connected than if we are not. Because if we are not connected yet, then we will be trying to get information about a path of a new device that has been added. While if we have already been connected, and I'm going to write that here, then we will be paying attention to the things that we were doing before, which is the listening to devices, but in this case that have information about the characteristic or the attributes of the Bluetooth low energy device. So we are going to have this comparison here. It complains about the match not being available. So we're going to move the match here. And now that we have the match ready, we need to, let me go down there, define the regular expression that we are using here. So let's, as we did before, let's define the regular expression here. And in this case, the regular expression is going to be similar. It includes like the MAC address and so on, but it's also looking for a service and a characteristic. And if we find a match here, then we're going to print that we have found a characteristic with this path, and then we will try to look in its dictionary to see if it belongs to this type of thing, and it will try to check the UUID. That is the UUID of the characteristic that we want to read. If you remember that, that was the temperature measurement. So by searching into this, we can now point to the characteristic that we were looking for. In order to have this characteristic read, we need to have, yeah, you guessed, another proxy. So let's have this proxy created here using the same format as we were doing before, as DBus create proxy, and we need to declare it as a field here. So let's have it declare in our header, and that is going to be our last one, I promise. So here we have this temperature attribute proxy, and we need to initialize it as we were doing before in the constructor. So we go to the constructor, and let's go to the beginning. In the constructor, we are going to define this new initialization that now uses the preamble to not only initialize the device proxy, but also the temperature attribute proxy here. Also to null pointer, because initially we don't know what is going to be the device path to the characteristic, the object path to the characteristic. Now that we have that created and we have it in place, we can go and define a couple of methods, one private, one public, as we were doing before. So we go to the header, and here we're going to define one that is going to be the public one, and one that is going to be the private one. So here we have these two methods, and now we can implement them. Let's go to the implementation, and here we go to the end of the file, and we create the declaration for the public. This is the public method. So this is going to be this one. I'm going to move it later, and here we create the private one. The private one is invoking a method, as in most other cases, and here we have method read, interface char, some arguments, and where we want to store the results. So let's go step by step and fill the blanks here. And the first thing that we want to do is to initialize the constants that we are using here. Then we want to give value to those arguments that we have here. In this case, we need to say that the offset that we want to read is 0. And we will be reading this offset and storing the result in this variant here. Oh, sorry. And storing the result on this uint 8 here. So this is an array of bytes that will be holding the value that we read from the sensor. Now that we have that in place, we can go and try to use this information and print it. So how do we get this value out? Well, the thing that we can do is just show the content of these results, and the part that we care about is the last 4 bytes. So it started on 0, so we want from 1 to the 5th byte, because those are the pieces that contain the temperature. The first one was a flag that was saying whether we had a temperature in Celsius or in Fahrenheit, and whether we had a timestamp or not. We are not interested in that. We just want the value. So now that we have this number containing just the things that we want for the temperature, we can try to create a new private method that is going to be, let me go to the header here, and in this case, we are going to have this, this new method that transforms from an IEEE 11073 format into a float. It takes this byte array that we have extracted from the temperature and converts it into a regular float. So now that we have that created, we can go to the implementation, and here we can have this method implemented. I'm not going to go step by step on the transformation because it's very similar to what we did in episode number 2 for implementing the BLE firmware in Python, in MicroPython. So same transformation, but the other way around. The first 3 bytes contain the value, and the last one contains the power to 10th that it is used to transform this value into something meaningful. It is complaining here because we don't have the math header included here. So this is the next thing that we're going to do. And now that we have that, we should be fine. So now pow should be available. Power is a function that is now visible here. And the only thing that we have to do is to use the value that we have read. How do we do that? Well, what we are going to do is here, after invoking this method that we have retrieved here, we're going to transform the value using the method, the private method that we have just defined, and print it as the value of the temperature. And now that we have that done, we can run this in the main thread so we can get the value out there. So let's go to the CPP, the main CPP file, and here I'm going to add the reading. Notice that first, let me include what is missing here so it doesn't complain. Sorry. We need to include thread, and now that we have that, should be perfectly fine. And I'm using delays here again because I should be using another conditional variable in order to know that I have connected and that I have seen that I have a proxy connected to the actual characteristic, but I haven't done that because I don't want to make this longer than it should be. And that is it. That's why I need these 2 methods here, these 2 implementations of a delay before and after getting the value. So that should be it. Now we should be running it and it should work. Let's try that and let's compile. And now we are going to run it again, trying to connect to our BLE device that I have black here on my table. So we have the binary ready and we use it, start scanning. It doesn't show my sensor. And why is that? Well, let me tell you why it is. Let me stop this program. And if you have this problem, what you need to do is you go to Bluetooth CTL and you see that you are still connected to the device. So the first thing that you have to do here is connect. And now you have to wait for a second. Now that the prompt is Bluetooth, you can power off if you want the device, and you can leave this interface and try again. And now you can see that the RP2 sensor is available here. It is trying to connect. We are still waiting for the connection to happen. Once it connects, it stops scanning, but it reads all the characteristics that we have. Information about things that are not a characteristic is printed, but it's totally irrelevant here. And once it has found the characteristic that it wants to read, it reads the value. These are the bytes, and this is the final temperature, 37.81 degrees Celsius. Don't worry, it's quite cold here, so it is just the temperature on the board, okay? So that's it. Finally, we need to disconnect from the device to leave the things the way we found them. We are great Boy Scouts. If we don't, the next time we run the program, it won't work because the sensor will still be connected and busy. Let's implement a method to disconnect from the device so we come back to the initial status. And in order to do that, let's implement it. Let's define it in the header. And we start by creating a public method here that is going to be called disconnect, and a private one that is going to be called disconnect from device. Again, the message will be in the private one. The public one will just offer the public interface. So now that we have both methods available, we're going to go and implement the code here. So we go to the implementation, and here I'm going to go to the bottom of the file, and I'm going to create the disconnect from device method. I haven't gone step by step because it's the same thing. We're going to have this call method asynchronous, and we will be invoking this disconnection callback once this finishes. So what we're going to do next is to work on the content of this method that is going to be first dealing with the error. If we get an error here, we want to print it and exit. And if everything goes fine, what we're going to do is to get the unique lock, the mutex that we have, we are going to lock it, and we're going to disconnect and access this thing that was the thing that we wanted to access exclusively. Once we have done that, the device proxy is also set to null pointer, and then we can easily unlock the mutex, so the rest of the threads can access to this data. And we just print this message to say, hey, we are done. That's basically it. Not much. So let's try to indent this to verify that everything is fine. And now that we have done this, what we would like to do is to have an implementation of the right. We're missing an it was here. So we're going to do the implementation of the public method, which is basically going to be an invocation of the private one with a new message. And that's it. Now that we have both pieces, we can go to the main file, and here we're going to disconnect from the device using the public method, and that should be it. Let's go and compile. Sorry, not this one, but this one. And we compile the project. We generate a new binary with the disconnect method. And with that binary in place, we're going to invoke it. And hopefully everything will be ready. But in order to avoid any kind of trouble, we're going to first use Bluetooth CTL and disconnect again, because it hasn't been disconnected because the method has been just added, but we are going to disconnect from the device, wait for it to happen, and then power off the Bluetooth stack. Now that everything is in place, let's run this. We find the RP2 sensor, the connection starts. We are still getting signals from other devices. Oh, and I got a correction error. That's something happens. And if that is the case, one thing that you can do is you can do sudo service Bluetooth restart. And then try again. We find the RP2 sensor. We'll wait for the connection to happen. If the connection is successful, we will be getting, oh, it is successful. We find the characteristic, we read from it, and then we get the temperature value. That's all good. And we disconnect from the device. And that was it. In this episode, I wrote a C++ application to connect to a BLE device and read values from the sensor. I have realized that writing C++ is not like riding a bike. A lot has changed since the last time I was writing C++ code that got into production. But I hope I did a decent job at using it for this small application. Feel free to make any comments. The biggest challenge wasn't the programming language, though. I banged my head against a brick wall every time I tried to connect to the device from my code. At the beginning, I didn't know whether it was my code to blame, the language, the library, or what. But then I started taking traces with btmon, searching in the internet, and after a while of not finding much, I realized that the problem wasn't the code, but rather the fact that I was sharing the radio frequency in a chip with a very small antenna. So the BCM43438, that is the chip that we use for Bluetooth and Wi-Fi in the Raspberry Pi, was creating these interferences for me for free. And once I used an Ethernet cable upgrading from a Raspberry Pi 3A Plus to a Raspberry Pi 4B, and connecting it to the internet using an Ethernet cable and disabling the Wi-Fi, all of a sudden things started to work. Even though the implementation wasn't too complex and the proof of concept was passed, the problem with the Bluetooth raised some concerns. It could only get worse if I talked to several BLE sensors instead of just one. I could still use a USB dongle and ignore the internal hardware. But before I take that road, I would like to explore the alternative, the MQTT. And that is going to be our next episode. Stay curious, hack your code. See you next time.